Hello again. In this video, I define orbit inclination and demonstrate this concept using our Satellite Orbital Simulator, SOS. Every orbit is defined by an inclination angle measured from a plane of reference. For Earth orbits, that reference is Earth's equatorial plane. So, if you launch from the equator and fly due east, your final orbit will have an inclination of 0 degrees. Now, open SOS, click on the File tool from the menu bar, and then select the default project option. Next, click on the Add Satellite button. When the Set Initial Parameters dialog opens, choose the Parking Orbit Insertion option, which assumes that the satellite was just launched into space. Then, choose the option to enter your initial parameters as latitude, longitude, and altitude. Note that the default values are 51.48 degrees for latitude, 0 degrees for longitude, and 200 kilometers for altitude, and represents a position in space over Greenwich, England. Change the initial orbit insertion latitude to 0 degrees, and then press the Tab key. Note that the yellow location dot moves to the Atlantic Ocean off the coast of Africa. Next, set the desired orbit inclination to 0 degrees, and press the Tab key again. Finally, click on the Set Parameters and Recalculate Orbit button. You should now see the orbit. Change the satellite image to red ball. Turn off the ground track. Choose to see the equatorial line from the display group box. And set the camera viewing from option in the camera group box to not controlled. Use the mouse to move the camera so that the equatorial line runs through the center of Earth, if not already there. Your camera is now in the equatorial plane. Note that the satellite's orbit is also in the equatorial plane. Therefore, its inclination relative to the equatorial plane is 0 degrees. Remember that latitude angle is 0 at the equator and 90 degrees at the North Pole. With an orbit insertion latitude equal to 0 degrees, you can choose to enter an orbit at any inclination between plus 90 and negative 90 degrees. However, if the orbit insertion occurs somewhere else with latitude greater than 0 degrees, the orbit inclination angle can never be lower than that latitude angle. If you launch to the east, the initial orbit inclination will be the same as the latitude where the orbit insertion occurred. Choose to edit the initial parameters for this satellite by clicking on that button. Now, change the launch latitude to 30 degrees and press the Tab key. Note that the desired orbit inclination changes to 30 degrees. Now, change the desired orbit inclination to 40 degrees, and then press the Tab key. Note that 40 degrees is an acceptable value because it's larger than the launch latitude. You can enter an orbit with this inclination by launching in a northerly or southerly direction. Use the radio button to choose between the two, and note the change in launch azimuth required for each. Choose the northerly launch. Then, click on the Set Parameters and Recalculate Orbit button to see your new orbit. To verify that the orbit inclination is 40 degrees, click on the More Information and Events button. Now, move the satellite to the first descending node by clicking on the Go to Node button. Remember that a node is where the orbit crosses the equator. You'll need to move the camera around Earth to see this. It should occur at about 31 minutes into the simulation. Click the Go to Node button again to move the satellite to the first ascending node. Again, use the mouse to move the camera to the other side of Earth to see this. This first ascending node should occur at about 1 hour and 15 minutes into the simulation. If you want to get into an equatorial orbit from an orbit with inclination greater than 0 degrees, a good way to do this is to do a rocket burn when the satellite passes through a node. In orbital mechanics parlance, an instantaneous change in velocity, magnitude or direction due to a rocket motor burn is called a delta V. Using the 40-degree inclination orbit you just created, do a plane change at the ascending node, so the result will be an equatorial orbit. Your satellite should still be at the ascending node where we want the delta V to occur. Therefore, click on the Add Delta V button for this satellite. When the Set Delta V dialog appears, set the desired orbit inclination to 0 degrees and then press the Tab key. Then, click on the Set Required Inclination button. Finally, click on the Use and Recalculate Orbit button. You should now see the orbit change that occurs at 1 hour and 15 minutes into the simulation. Note that the delta V required is about 5,332 meters per second. The yellow arrow shows the magnitude and direction of this velocity change vector. Now rewind and then run the simulation. If the satellite's inclination is 90 degrees, it's in a polar orbit that flies over Earth's 2 poles. Watch the night sky about 30 minutes after sunset to see these satellites passing overhead. They are visible because they're still exposed to sunlight. Watch for tiny bright dots that look like stars but are moving slowly across the sky and not blinking. Blinking lights are aircraft. When the satellite enters Earth's shadow, you will no longer be able to see it. We hope you found this video useful. If so, please give it a like. If you want to be notified when we add more videos, click on the notification bell. Finally, leave a note if you have comments or requests for new videos. Goodbye.